Now we're ready to move on to section 11.3, and from section 11.3 we're interested in the product rule for radicals. So think about the word product. Product means multiplication. So we have the nth root of a multiplication problem, a times b. And the product rule for radicals says that we can take this nth root of a times b and break it up into two separate radicals. The nth root of a times the nth root of b. Now notice the same index is happening all the way through. We can't change the index along the way. So if this is an n, these both have to be n's as well. So now that we know the product rule for radical, we're ready to do example 2, which has the directions simplify. So for part A, we have the square root of 45. Now the first thing that you want to notice is that square root of 45 is not something that we can evaluate like we did in example 1 and get a nice integer value. So this is not asking you to go to your calculator and find an ugly decimal answer. What this is asking us to use is the product rule for radicals in a very special way. So what we want to do is change this 45 into a multiplication problem so that we can use this product rule for radicals. Now, I don't want to just do this multiplication problem in any way. I want to make sure that my first factor is going to be a perfect square. So if you think about the number 45, and you think about different ways of rewriting it as somebody times somebody, one way of rewriting 45 is 9 times 5. And 9 is a perfect square. So I'm going to put 9 in my first spot, and then I'm going to put 5 as my second factor. Well, the product rule for radicals says if you have the square root of a product, two things multiplied together, you can break this up as the square root of the first factor times the square root of the second factor. Now, because our first factor is a perfect square, that means that we're actually going to be able to evaluate that first piece. The square root of 9 ends up being the number 3. So we have 3 times the square root of 5. Now, to determine if we're done with this problem, we need to look at that square root of 5 and ask if we can simplify that even further. If square root of 5 can be broken down in much the same way here, where we can rewrite it as a perfect square, more exciting than 1, times something else, then we would go ahead and do that and keep doing that until we can't break it down any further. So in this case, square root of 5, that's as simple as it's going to get. So we're done with this particular problem. The final answer on this one is 3 times the square root of 5. Now for part B, we're interested in the square root of 200. So once again, I want to rewrite this as a perfect square times somebody. Now if you think about this for a bit, some of you are going to get different squares that are factors of 200. However, as you think about all those numbers that are perfect squares that are factors of 200, the best way to move forward is to find the largest perfect square possible. So is it true that 4 is a factor of 200? Yes. But if I start with 4, then I'm going to have to, at the end, do a lot of simplification and just keep on doing it. So if I can find somebody who's bigger than 4 that's a perfect square, my process is just going to be simpler. So if I think about it a little bit more, eventually I can get to the fact that 100 is in fact a factor of 200, and it's the biggest perfect square that is a factor. So that's the one that I'm going to use. We're going to have the square root 100 times 2. Now that we have that, once again, the product rule for radicals allows me to break this up as the square root of 100 times the square root of 2. Square root of 100 then is 10. So my final answer on this problem is 10 times the square root of 2. Now, again, if you chose to have your perfect square being the 4, what would happen is you would get down to an answer here, or at least a tempting answer here, where the square root could actually be simplified further. So anytime you look at these, you should always ask yourself, can we simplify the radical part more? And if the answer is yes, keep doing it. And eventually, you would be able to get to the same answer. So the final answer here is 10 times the square root of 2. If you choose a smaller perfect square to begin with, you're just going to have to do more steps along the way to get there.